Good morning, everyone. I want to welcome you to day 3 of the Global Water Futures annual meeting. My name is John Pomeroy, and today we're focusing on knowledge to action, harnessing data and knowledge to improve water practice. And this is our plenary session where we have 3 very esteemed keynote speakers who will address this from the value of open reproducible data to life stories with water, to water prediction. And so I would like to introduce the first of these speakers, and this is Jerad Bales. Jerad is the executive director of QUASI, which is the Corporation for Hydrological Sciences in the United States. It's a massive organization. He develops and implements overall strategy for QUASI, maintains relationships, and with this, and ensures the sustainable of that organization, which is one which many Global Water Futures institutions are in fact members of, and very happy to work with. Before joining QUASI, he was with the U.S. Geological Survey as a hydrologist and managing the North Carolina Water Sciences Center, and it was chief scientist for water. So he comes to us from the United States now, and will speak on the value of open and reproducible data in water prediction. Jerad, carry on. And remember, we will have questions and discussions at 10:30 to 10:50. And one last reminder, there were some technical problems yesterday with our people getting on our presentations. They're all recorded and up on the website, so you can watch them in the future at your leisure. But Jerad, I pass it over to you. Thank you.
Thank you. I'm happy to be here today. So I'm going to share my screen. Well, sorry, it worked a minute ago. Okay, great. Thank you. And thanks, Josh, for the little technical hint. And so, as John said, I'm the director of QUASI, the Consortium of Universities for the Advancement of Hydrologic Science, Incorporated. We are nominally located in Boston, although since the start of the pandemic, we kind of scattered to the wind. And so I'm speaking to you from North Carolina today. So I like to start many of my presentations with this particular statement. It's the title of a paper in the journal Water Resources Research. It says most computational hydrology is not reproducible. So is it really science? Since science is supposed to be, of course, reproducible. This is some guidance from the Institute of the U.S. Institute of Medicine, part of the Academy of Sciences, and it comes via an investigation into some research, cancer research that was done, and the work was not reproducible, and so the Institute got involved in looking at it. But one of the statements from their final report says, computations should be locked down and repeatable using scripting languages so that an original set of data, all steps of analysis with an original set of data, all steps of analysis can be repeated and documented, guaranteeing robust data provenance and reproducible data management. So science really is supposed to be repeatable, replicable, which means someone else can take your experimental setup or your model and get the same results, and reproducible, which is getting the same results with a different team. You know, I don't know if anybody thought that this was a little bit ironic, but you know, there's a paper in Nature from a few years ago that addressed this question, the title, which is The Growing Inaccessibility of Science. And most of us without a institutional library subscription don't want to pay $9 or $200 to access science. And so perhaps this is part of the growing inaccessibility. So I really don't want to talk too much about reproducible hydrologic modeling because, you know, University of Saskatchewan, you've kind of got the experts there. This paper by Wooter and Martin just recently talks about approaches to having reproducible workflows in hydrologic modeling. And so if you haven't seen it, I encourage you to take a look at it. There's a URL there in the slide, and these slides will be available to you. There's also another paper that comes out of the Quasi work in which HydroShare, a platform that Quasi operates, was used to do reproducible hydrologic modeling by linking the database or the online repository, which in this case was HydroShare, through APIs to a computational environment. In this case was Jupyter notebooks, and then storing the data back in the online repository. And so this is another approach for reproducible modeling, these workflows that can connect repositories to models through APIs and then back to the repository to store the results. But all of this requires some data infrastructure to support. Supporting fair data, findable, accessible, interoperable, reproducible data and workflows requires data infrastructure. And so with that kind of comes some questions that scientists need to try to work through. So first of all, you know, which repository do we use? I mean, there's lots of repositories that are available to you to store, for which you can use to store your data and to store your workflows. One of the questions that, you know, we often address is, do we use a domain repository, domain-specific repository, like HydroShare, Quasi HydroShare for water, or do we use, you know, as a scientist, do I use a general repository like my institution's library, for example? And, you know, there's advantages to both. The advantage to the domain-specific repository is that, you know, you can go to one place or a few places to find, for example, water information. Most government data producers, which in fact do produce a lot of the water data, have their own infrastructure and some requirements around that. Access can sometimes be an issue, in particular, accessing workflows that go from field data to the final published data is not always easy through these government repositories. You know, we think at Quasi, we think of software as infrastructure. For example, Quasi's hydrologic information system enables discovery of time series data across more than 100 data producers all in one place. But that platform is now over 10 years old, and just like infrastructure like roads and bridges need periodic repair, software gets potholes too, and so we have to fix that. And so currently we're working to modernize HIS system, and we're also working to do some additional, I wouldn't say modernize, but updating to HydroShare, which actually was begun in 2011 and became operational in 2017. the people that fund some of these domain-specific data repositories, in our case, government agencies and the U.S. National Science Foundation, the question that they always ask is, what's your sustainability plan? How are you going to keep going after our funding ends? And so that's not an easy question to answer, because privatizing, for example, these data repositories doesn't seem to really be practical at this point. No one is particularly interested in sustaining funding for them. And some data repositories are now, getting multiple decades old. And so I guess our sustainability plan is to continue to receive this support from the U.S. federal government and foundations, but that's probably a little bit of a weak sustainability plan. But how do we keep this infrastructure continually funded? I mean, how hard it is to get hard infrastructure updated and funded. Everybody likes to build a bridge or build a road, but nobody likes to pay to keep it or repave it. And so it's a little bit the same way with software infrastructure. Another challenge that we face as builders and maintainers of data infrastructure is that the smart people that know how to do this and know how to do it well can make a lot more money working for the Googles of the world than working for a nonprofit. And so how do we motivate people? How do we get people, the smart people with the modern skills, to help with maintaining and updating data infrastructure? And so we like to try to find people who are motivated by the mission as much as or more than by the funding. Another question that we are beginning to think about is, what do we do with massive data sets? So, for example, these models, these regional scale to continental scale hydrologic models that have data, every 5 minutes or less over multiple variables over large regions. What do we do with these massive data sets, and how long do we keep them? I think that's a question that hydrologists need to begin to think about, because while we do want to maintain model data and model output, we need to think about the practicality of that. And then finally, it's kind of the long tail of science, or the long tail of data, data rescue. When I was at the USGS, in one of the offices I was in, there were paper copies of stream flow measurements dating from the 1890s in the file cabinets. And, that's in some ways, that's a treasure trove of data that's, more than a century old, that documents changes in channel morphology at multiple locations across the country, but those data are not really electronically accessible. And so it's valuable data, but it's not accessible. And I'm sure you can identify multiple other situations like that. But one of the things at Quasi that we're starting to think about is knitting together different repositories. So Quasi is supporting the U.S. Critical Zone Thematic Cluster Network, and we're building a submission portal that right now links EarthChem, which is another repository for sample data. So, for example, soil chemistry and water chemistry and rock mineralogy and so on. Linking that to Quasi HydroShare, linking it to Open Topography, linking it to Zenodo. And so through this data submission portal, regardless of the kind of data that you may have, critical zone data, you will be able to be guided through this portal to the proper repository with the proper metadata. And so this is just a mock-up of what that is looking like. We actually have a version on beta now, but these kinds of approaches that we're using for critical zone data, and critical zone is from bedrock to treetop. It's kind of the moniker that we use. But knitting together different repositories for a particular scientific project, if you will, seems to be seems to make more sense than building a brand new repository. There's plenty of repositories out there, and so in this particular case, the user doesn't have to think too hard about which repository to go to, but then can enter the data through this data submission portal. So what about discovery? Once the data are in the portal, how will discovery work? Well, we think it'll work by, our design is to build a metadata catalog for all the data, regardless of where the data sit, which repository. And so then discovery works on the metadata catalog and then goes and retrieves data from the proper repository. But, we think about more than just open data, but also open science. And this is from a US National Academy's report on open science. And then basically it says, the scientific process should be open from beginning, in which an experiment or a field campaign is thought about until the end, when there are data and models and results to be maintained. There's challenges and there's benefits, of course, to open science. The challenges are, of course, the cost and infrastructure. Publication models don't really support it. There's not always a supportive culture for this, particularly in academia. There are privacy and security concerns. And then there's just differences in the way people do science. Ecologists do science differently than hydrologists, who do science differently than geologists, and so on. And so those are some of the challenges that have to be overcome, especially when we think about interdisciplinary science. But the benefits, there are also plenty of benefits: greater confidence in the results, improved scientific rigor, because the whole community can look at the process, and when that happens, there might be opportunities to address new questions by bringing new people to the table with a more inclusive culture. And it also, from a research point of view, from a science point of view, it's an investment in the scientist's future. But open science is more than just about open science. It needs to be open to more voices, and I'm happy to see that in this particular symposium is open to plenty of different voices. COASI's currently hosting a series on hydrologic science and indigenous voices. In fact, one of them is today in a few minutes, and then continuing for several weeks. But many of the people involved in the scientific enterprise are from similar backgrounds. There was a study that was done recently, that said, how do we attract underrepresented people to the sciences? And so in many cases, particularly in the US, you see these advertisements that say, come work in the national parks on, water problems, or, enjoy a project in, wherever, somewhere in the outdoors. And of course, many of the people, particularly underrepresented voices, have never been camping with their families or hiking when they were young. And so these kinds of approaches are probably challenging for them. It probably doesn't appeal to them. And so we have to think about different ways of attracting more people and being more inclusive in hydrology and in the water sciences and geosciences. Finally, I wanted to talk a little bit about participatory modeling. You know, all water modeling is not, for example, just about floods, although we often think about water modeling for floods. But, you know, much of water resources or water modeling, hydrologic modeling, is about allocation and water management. And so participatory modeling allows the entire community to weigh in on the modeling process, and then makes outcomes more transparent, and perhaps there's greater buy-in. This is a challenge sometimes for scientists to think about, you know, involving the community into the modeling enterprise, but perhaps the outcomes will be better, particularly on water allocation and water decision making. You know, if there's a certain amount of water that's available in a particular region, you know, helping the community think about that and thinking about what the options and the trade-offs are is of real benefit. And so open science, you know, is not just open data, and just most of our lifetimes, many of our lifetimes, we've seen that we moved from ink to digital text, and we've moved from desktop computers to a global network. And so results can be shared instantly and pretty easily. And so there's not really any technological barriers to open data and open science. And so a lot of the barriers still are institutional and cultural barriers that I think we need to work hard to overcome. So this presentation is on HydroShare, and you can visit our website here. And thanks again for the opportunity, and good luck for the rest of the morning.
Well, thank you so much, Jerad, for a wonderful talk. And you'll find many supporters in Global Water Futures about the needs to share our data openly, to share our models openly, and to ensure that we have rigorously defined the structures and procedures for doing so. So we appreciate the pioneering work that you and the Quasi network have done over many years in this area. So thank you. I also appreciate your segue to listening to different and Indigenous voices here, and so I'm delighted now to introduce our next speaker, Elder Mary Jane Johnson. She is an elder of the Kluane Man Ku Dan, which is the Kluane Lake First Nation area, and someone who has worked with Parks Canada for over 40 years in protected areas, environmental, cultural, and Indigenous language issues. She is a great-grandmother, a champion for Indigenous language revitalization, and a great leader of her community. She also lives in and protects one of the most incredible regions in the world, the Kluane National Park and Kluane Lake region, which is an absolutely incredible place. So she's involved in many committees and advisories, from the Canadian Mountain Network to the Truth and Reconciliation Commission to others. And it is a great delight and honor to have her here. She is going to speak about life stories with water. And Mary Jane, pleased to see you. Your video looks upside down, which is interesting. So, but anyway, hopefully I think we can hear you. So it's your voice that matters.
Well, I don't know why it would be upside down. I did have some difficulty this morning hearing.
Yeah, it could just be on
very
mine.
broken.
So, yeah, don't worry, just proceed. I think I'm hearing it's just on mine. So that's something about my computer. So anyway, carry on.
Okay. And Leo Shokothan, are you able to hear me?
Yes, we are.
I'll
We are
carry
able to
on.
hear you clearly.
Good morning, Dunch A. Hello. Jean Goudia Uye. Guch N.A. Mary Jane Johnson. Ama Tutlesen Uye J. Ama Tutlesen Guch N.A. Lena Johnson Uye J. Asua Goudia Uye J. Na. Usually when we're going to introduce, we're going to introduce as far back as we can on our mother's side, as far back as we can on our father's side, to let people know where we come from. When people ask you, an elder once told me one time, Harry Brom up in Skudia, yeah, it's Skudia, but if you tell me who's that your grandmother, Ina, then I know who you are. I know that you are my relation. So that's important to have that kind of ties between each other. Those kind of ties between each other as people were also brought up with that we have that kind of ties to the land on which we travel, on the waters that we travel on, and also all the other living that is on that land and those waters. Days from when Manan e show ni that the days are getting longer right now, and in 30 days, the days are going to get shorter. And we still have Kwasho, Yo, ni Hyo. Yesterday, about this much snowing yet. We should be having the lakes open. The lakes are only open maybe a meter at the most. The ponds are still frozen. This is 1 month behind. All of these migratory birds are just pushed into whatever open water they can find to look for food. They're just digging wherever those dagai, wherever the swans are digging, is just flock of smaller birds around them trying to get whatever food that is left so that they could eat. I had a chance this weekend to go and watch for a while that what's going on in some of those open waters. In our way, we identify land areas, water courses, spring water, gel, spring water, and we sing songs about them. We tell stories about those places and those water courses so that people will know. The young people that are coming behind us, they will know which way to go to be safe, where to get good water, where to find shelter, where you look around at a lookout, where there's abundant game down below, or on the side of the mountain, or in that big meadow. Right now, a grandson and granddaughter and her partner, they're gone out, going to look for oa. They're going to look for grayling because the creeks are open and they are flowing. This year we had almost a meter, a little over a meter of snow on this land. And usually because of where we're situated, Mount Logan is just over that way. about maybe 90 miles, not even 90 miles this way as a crow flies, they said. We're protected usually from all of the big snow that would come in from the coast. We usually don't ever see that kind of snow on the ground. And this year, we're still getting snow yet in the month of May. My mom is 93. Ma is 93. And she said, I never ever seen this in my lifetime. And mom pretty clear in her mind of what she knows, what she's seen in her lifetime. She spent many, 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 many times walking on this land, traveling on that water. Not only is the change that we're seeing in the amount of the amount of snow that we're getting, we're also seeing that in the length of time that land is not melting. We're into 30 more days, and then the days start getting shorter. All of the other animals that are living right now, that are having babies out on the land, they are we're just worried about them because that Kenai, the moose, they need that water. They need that water. They bring their babies, their newborn, they bring their babies out onto the open water for protection from grizzly bears, from the wolf that comes after them, after they're young. On the side of the mountain, we know that the sheep are going to have a hard time. All of their newborn are just coming right now. In the next week or two, their newborn, all of those babies are born. We dig around underneath the top grass. They're looking to how much green there are down below for the young ones to eat, and we know that they're going to have a hard time. It's just not there. We also are faced with heat that is just incredible sometimes in the summertime. We've gotten up to 30, 33. And for us in this part of the world, that is hot. That's really hot. And with that kind of heat, we are dealing with melting permafrost. So the melt underneath the ground it has caused lots of extra water to be on the land during the summertime. And it eventually will move out of the land area, but usually around June, July, we're seeing lots more water on the land. And with the melting permafrost also, we see lots of sloughing on the mountainside. So like a whole side of a mountain will just come down. We've seen this just recently here in Whitehorse, where one of the roads is just blocked off to the downtown area. There's only one access road into Whitehorse, Yukon at this time because of sloughing on the side of a clay bank of a river. We're seeing this quite a bit around the area. Several years ago, Chu dried up, the river, Slim's River. We call it Chu by itself water. This dried up. We thought, what happened? So what happened up on the top of the ice fields is where the Valley Glacier comes off of the ice fields, the Cascawelge, and the south arm comes in on this. We asked, what happened? What's causing this? They went up and checked, and the meltwater river coming out of the Cascawelge comes down, joins the south arm, and it usually melts and drains out toward Kluane Lake. This time it joined together and it started draining down toward the LSAC, out toward the Pacific Ocean. And this caused all of this water to dry up that was on I-2 coming into Kluane. We didn't see it that year, but the next year we saw the water level drop. This time last year, we during the winter, when we're setting our nets underneath the ice for fish, that's one of our main food, we see that we had to change where we had set our net for my whole lifetime. We set nets there. We had to check and change and re-drill holes. Even from last year, that water level has changed, and it's dropped down about close to 3.5, almost 4 meters in height. That's how much the water has dropped down. So we are caused now to find out what all a new way to pass on that information to the next generation, because our travel on the ice in the winter time, we're always careful about, be careful around this area because spring water comes in to this part of the lake. Well, now the spring water has changed where it's coming in on the lake. People have fallen in on the ice. We're blessed that not more people have passed because of that changing of how to travel on that ice, because of where the spring comes in, because of the time that the ice is freezing. We used to be able to go across the lake. I know David Suzuki doesn't like that word. We used to be able. We would go across the lake on a dog team at the end of October, in the beginning of November. We'd set our nets underneath the ice and we'd get about 200 whitefish to put away for the winter, put away to feed the dogs, make sure we put all the ones with the fish eggs over to the side so that we could have that kind of treat throughout the winter. Now it's January. If we're lucky, around the end of December, we might be able to set a net on that ice, but it's usually now into January that we go out and we test the ice. One of my brothers might go out, or one of our grandchildren might go out, and they test the ice, chop it out with a tunnel with a chisel, and know that what kind of depth that ice is before you could travel on it. These kind of stories and that are ways that we share our information for our children to be safe on the ice. As they travel on the land, we tell them which way to go on the trail, how close to go on which mountain. Mountains got names, so we, in our way, because the stories are associated with those mountains. That it's not just named after some geologist that worked up here for 2 months of the year in 1942. The stories and the place names on those land areas and the water areas are older than what we know. That it's been passed down so many generations that it's with me, and now passing it to the next, to grandchildren and great grandchildren. When they go out into the land, we tell them which trail to follow, how close to the mountain. And when you come to this draw, you're going to see 2 forks like this of a creek. This one right here is really the one that you pass this creek and then go to the next one, because that is the one that has good spring water. That's the one that's going to give you good tea, good water to drink. All the time when we travel on the land, we used to be able to use our hand, just dip our hand in the water and drink like this. Nowadays, we got to be careful. Miners working up in that area, we've seen oil on top of the water, way back up in the mountains. How did oil get back there? Miners. Never seen oil in the water before, but now there's oil in that water. Makes you sort of sad to have to tell you that kind of story. But that is true, what's that I said. Lots of places and that people say they want to look after how you manage water. That time that we told the community people that they're going to put in a well to take water out of the ground, that we had to find out where the water was on the land. Here, those elders, they got those witching willows, and they said, come, we'll show you where that water is. They showed us where that water was on the land. And I'm serious, when you hit that water, that willow pulls down like this. It just goes like this. So it's not only technology that has information. Please don't let that technology keep your information. You have to be able to share knowledge of what is on the land with the generations that are there coming ahead of you. They're going to walk on this land too. You have to be able to let them know where there's good water. The elders showed us where to get the water that's flowing underneath the ground. So they put the well there, sure enough. How many years now? That only one well that they had to change because of the groundwater switching underneath the ground. All the other wells that the elders showed us, they're still operating. They were a little bit upset when they told them that they had to put cleaning inside of this well water because of the high minerals in that water. And they were worried that by putting this inside of the water, that you were also taking away the ability of your body to work with water. Because they tell us, grandmothers tell us, have told us that you are walking water. What water you drink this way, you are walking that water in your lifetime. You become part of that water. And thank you to Elder Virginia Smart from Teslin, Yukon, who reminded us that we are part of the land and part of this water. I think I might have hit my time. I still had a little quick story. How much time that I have there, John Pomeroy, but I had one little story about.
We would love to hear the quick story.
Okay. This is a story from Angela Sidney told us in 1976. I was part of a group of people that were blessed to hear our elders that were born on the land to tell us stories. Long time ago, Raven is flying around on this land and he's looking. He sees an island, and on that island lives seal woman. It's all water. It's all water. on that island lived seal women. Once in a while there was a driftwood that would float by, and Zerg-E would sit on that and he'd go, where does driftwood come from? Where did it come from? Sure enough, one day he sees that island, and on that is seal woman. While that seal woman was busy about something, Zerg-E came and he took that seal woman's pup, the baby. And he told that seal woman, dive down into this water and bring up some of that earth so that this could be shared around the world. So the seal woman said, no, I can't. He said, I'll hold your baby until you do. Seal woman dived into that water and she brought up this dirt. Zerg-E took that dirt. He broke it like this and blew it. You know how sand floats on top of the water? When you throw sand on the water, it floats on top of the water. That's how this earth started to be formed. Not enough yet. He asked that seal woman go down again. Seal woman went down. He bring up some more dirt. Zerg-E did the same thing. Blow it all around. And all of this earth started to form. From there, people came to be. If I'm gonna tell you this story, you're gonna have patience, because it is about 2-3 week story to tell you how Zerg-E continued to make this earth, and how Asuya, that beaver man, how he was part of making this earth how it is today. We're on a blue planet, and this blue planet here is really who we are. We are part of the land and part of the water. Klahu, that means is finish. Shonidan for this opportunity.
Okay, thank you so much for that and for the lesson and story at the end. It's a great gift to everyone in Global Water Futures. Thank you so much, Elder Mary Jane. Our next speaker, I would like to introduce Dr. Al Pietroniro, who is professor and Canada Research Chair at the University of Calgary in the Department of Civil Engineering. Dr. Pietroniro, I've known for a long time. I remember him arriving at Environment Canada in the early 1990s, saying he was going to create the water model for Canada, which we all thought was very, very ambitious. But what we didn't know yet was that Al does what he says he's going to do. And so happy to introduce Al and hear about the innovations and in Global Water Futures advancements in hydrological modeling. Dr. Pietroniro.
Thanks for the nice introduction, John. And yeah, it's been a busy career. Before I start, though, I'd like to acknowledge that I'm in Calgary, so I'm in traditional territory with the people of Treaty 7, and the city of Calgary is also home to the Métis Nation of Alberta, Region 3. So I'll go quickly through this talk. There's lots of slides, but they're just kind of giving a flavor of what's going on with our modeling efforts. As folks know, the core modeling team is pretty large. It's about 40 people, give or take. But I'd like to acknowledge my co-authors here, John and Martin and Corinne and Shervan, who's helping lead the team now, and Bradman, who's moved to Alberta Environment now, but was part of the main part of the core team. So just a reminder quickly, there's a whole series of themes, and we've actually recently added a human dimension theme as well to the core modeling efforts. And so these are all interrelated in some way or another. And I think as we heard in the previous talk, there's a strong tradition of understanding that with our First Nations in Canada. And so scientists are coming to that realization as well, that it's all connected. So I just wanted to go over a few thoughts with respect to what we're doing, and this ties in tightly, I guess, with Jerad's talk earlier. We've been pushing for these open model principles, open source principles, and so in general terms, I guess, our overall modeling approach has really been to develop things that were digestible by the user community. We had strong version control, and really strong numerics and strong efforts with respect to some of our computer science efforts as well. And everything we do is pretty much scripted or open source, and so I'll go over that in a second. Just a quick reminder too for folks of kind of the domain we're looking at here. So it's pretty much all of Canada. We've set up systems in subbasins all through the regions here. I should mention too that actually when you look at the Hudson Bay drainage, actually the group at Calgary through Trish Stadnick have run HYPE, Arctic HYPE for that whole domain as well. So we actually cover pretty much in one way or the other the entire country. And of course, some of the work that Martin Clark has done actually is global. And so, it's not exclusive to this, but this is where we focused our efforts. So we're kind of in the home stretch with what we're doing with the core modeling team. There's some key areas of delivery here. So we're doing current gen modeling that includes mesh, HYPE, CRIM. Those types of models are really reaching sort of their completion in terms of the models themselves, and we're really focusing on applications and diagnostics. We've done a lot of great work on the geospatial intelligence side, and as I said, the global SUMA runs are complete. That's Martin's team. We've done a lot of interesting work on visualization, which I'll show in a second. And we're also moving to the next gen system, right? And so everything we're learning here is really helping us with kind of the next level of modeling. So I'll just go through a few of these in terms of spatial meteorological forcing. People have seen this slide before. So the CONUS 2 simulations, that's a collaboration with NCAR. Those are the climate simulations we're doing. Hopefully they'll be done by the summer of 2022. We've got ongoing GEM simulations. So these are things that are still ongoing or coming up. And we've looked at doing our own GWF downscaling product. So Simon's going to lead that for us. And we're expecting some results in the fall and winter of 2022. So all this is moving ahead. And of course, we have our standard data sets that you've seen before. So just quickly, this is an example here of work done by Guochen Tang. This is the ensemble meteorological data set for North America. There's a whole series of data sets available. And you can, if you look at our GWF core website, you'll see the sort of current climate data sets and the future climate data sets as well. So this is an example of a current climate data set. And this is the one that we're developing now with Simon's team, looking at basically downscaling a series of WCRP realizations and using a semi-parametric quantile mapping methodology. So a little different than what we've seen before. And we hope to have that done at least precip and temperature by early fall, and then have the other forcing variables we need for the models like radiation and humidity sort of towards late fall or early winter. The other effort we've focused on is geospatial intelligence, and actually Jerad mentioned this particular paper by Wouter, where we're really looking at developing a geospatial framework where pretty much everything can be considered model agnostic. So we've made a lot of, where we put a lot of effort into developing all of our codes. So, whether it's mesh, HYPE, or CRIM, to be able to work in that model agnostic framework. And so we're really pleased that that's coming along and moving ahead quite quickly. And so we have a team of people actually trying to develop that and make sure that we're consistent. So the whole idea of this model agnostic framework is to really improve the efficiency of continental domain modeling, also make it easier to collaborate and easy to reproduce results, as Jerad mentioned earlier, which is a real problem, I think, in our science. And so the real sort of mantra here is advanced community hydrological modeling rather than a community hydrological model. So make it so that the models that people have developed for whatever reason are actually comparable, usable, and repeatable using this framework. Just a couple of slides here on some of the models. So the CRIM model. So here's an example where GIS, this is the Bow River to Calgary. This is an example where GIS information was used to generate 2,500 HRUs. Those of you who know the CRIM model, it has very realistic algorithms. And it's used, developed by John Pomeroy, fairly sophisticated model, has everything we need to run a model. And so we're now tying that to the model agnostic framework, and John and his team have done a lot of work in moving that model forward. So the next generation of the CRIM model will work with the model agnostic framework. Is open source now. It compiles in both GCC and VCC. So we've moved some of the dependencies, I guess, is the best way to look at this, from the old Borland compiler, and there's some built-in dependencies that are now kind of taken out. And so it really does fit this sort of framework of open source data. So the new version of CRIM will tie in with everything else we're doing in the program. The mesh model, everybody's seen this before. This is the Canadian land surface model tied with the hydrology wrapper that we've been developing. It was developed at ECCC, but also a major part of the program here. And so that model's been set up, and we've now moved to a vector version of that model as well. And so that ties into the model agnostic framework as well. And now we're doing what I would call sort of production runs, I guess, for the model. And we're doing the same thing with HYPE. HYPE is actually moving to a model agnostic framework as well. So you can see that all of the models are moving to this agnostic view. And we're doing a lot of benchmarking. So what that allows us to do is actually compare the different models and see where where the differences are, and try to understand why the differences are there. Just to give you a sense of the global model application. So this is SUMA, and this is Martin's famous horrendogram, as he calls it, with how his model's designed. And it's tied to the meso-route routing model. So again, with this agnostic framework, we're able to actually switch out routing models between the different systems. So, it is possible to run something like CRIM with the meso-route routing model, and you can do it at a continental scale technically if you wanted to. And so that's the beauty of moving to this type of effort. So this gives you an example of some of the work that's been done in the region. I won't go into the details here, but you can see that we're actually able to estimate, or Martin's group is able to estimate mean stream flow and look at uncertainties in that stream flow at a global scale. So these are early results for sure in these models, but the capability is there now with this framework. So just quickly, we're moving to a next generation hydrological modeling platform as well. This is a lot of work done by Chris and the computer science team, looking at really a flexible structured, it's an unstructured triangular mesh, but looking for a flexible structure in terms of the hypothesis testing in the model. It's using existing codes, and it's using particularly modular and physical equation structures. So it's based on a hierarchical coupler. Some of you have seen some of the work from this with things like Snowcast, which is kind of a quasi-operational product coming out of this. But there's more work being done on this front. So Chris provided these slides. There's updates on innovation with CHM. I won't go into too many details here, but I think what's important to know is CHM can now interact with hydrological subcomponents of SUMA using a wrapper. And so again, we're looking at this from an open source perspective here, so that a little bit of plug and play, I guess, is the way to look at this, right? So we'll see where that leads, but a lot of effort on innovations in CHM. There's also been some work on the geospatial side with CHM, looking at generating improvements. And I think Chris has given a talk today on this. So I would suggest, if you're interested in that, you go to his talk. So this has all led to kind of a bit of a larger vision. This is going to be a bit of a post-GWF vision, where we're going to work through the Cooperative Institute for Research to Operations in Hydrology. This is a fairly major U.S. initiative funded by NOAA. And so we'll be collaborating with scientists in the U.S. to advance the hydrological predictive capabilities across North America. So we're moving away from just Canada to a North American domain, mostly focused on forecasting, but there'll be a lot of other efforts as well. And again, looking at this unifying hydrological modeling approach, and improving our model representations, looking at dominant hydrological processes. Obviously, in Canada, we have strong cold regions focus, but we're going to bring a lot to the table, I think, for this group. And so there's a computational infrastructure part of this as well, which is quite exciting. And so we're looking at basically summit to sea type of modeling here continentally, and I think there'll be global ambitions as well. So that's going to be where we're going over the next little while. Just quickly, there's a visualization project as well. So working with Kevin Schneider and his team to see how we can actually develop an interface that allows us to diagnose and look at our models. Again, this is really focused on an agnostic approach. Pretty much all of our models have moved to some form of a NetCDF format, and so we're trying to develop an API and a library. This is the work that Kevin's done to make sure that we can actually diagnose and look at and understand how our models are performing. And this approach should be available to all the modeling frameworks that we've developed. And so here's a bit of an example of what it looks like. It is a scriptable code, so you could actually write your own scripts, or you can use the programmable interface and do things there as well. So depending on your level of sophistication, we wanted to make sure that it was accessible to people. So as everybody knows, you tend to write a lot of scripts to do the same thing over and over again. So this allows us to do that. But if you want to just investigate something quickly, you have that possibility as well. So we're pretty excited about this, and this will be a nice legacy, I think, as with all the models as part of GWF. Last couple of points on the knowledge mobilization side. As everybody knows, this is a necessary conversation we need to have, working with Corinne and others to develop a bit of a strategy here. How do all these efforts make their way into operational agencies? How do they become useful? These are not easy things to answer. How do you actually measure success? And so we're spending a lot of time now towards the tail end of GWF to develop our understanding of how this all works and try to influence different agencies. We've been successful with the forecasting groups across Canada, at least with some workshops and that kind of thing. But we'd like to take it to the next step and make sure that a lot of this work ends up in operational settings or is useful to local stakeholders or rights holders. Just quickly too, we're now moving into the human and health dimension. So the outputs of these models, we're looking at things like infectious disease, vector-borne disease, flood and drought resilience. So how communities actually end up behaving, and what kind of information could we provide for local decision makers. And then we're also looking at governance in these systems and see if we can influence some governance as well. And there's been a lot of work by John and others on trying to influence the Canada Water Agency, which we saw earlier in the week here. And last thing quickly is the Planetary Water Prediction Initiative. So we've been pushing really hard, at least in high elevation areas around the world, and cold regions like the Arctic, the Himalayas, the Andes, Central Asia, to apply our models because they were designed for that. So again, going back to this model agnostic framework, we should be able to apply, and we are starting to apply all of our systems in these areas. And so hopefully we learn a lot and provide input to those folks. So just a quick summary, John. So, the computational infrastructure to enable large domain hydrological modeling is pretty much on its way to being completed. And we're now focusing on climate change analysis and some diagnostic modeling. We've developed, I think, a really robust model agnostic philosophy within the core team. That includes the visualization. It also includes the community hydrological modeling and advances in sort of our community of practice on how we share code and that kind of thing. So I think by the end of GWF, we'll have developed a state-of-the-art capability and prediction, and really looking forward to moving ahead as things go. So I think I'll leave it there, John, and thank you very much.
Okay, great. Thank you so much, Al. And so at this point, we have time for questions for all of the speakers. And so I'd like to ask Mary Jane and Jerad to come back on if you still have your connections. And we'll take some questions from the audience. And while they're coming back on and we're getting the questions, I'll start with a question for you, Al. You mentioned the commitment to open source modeling and open data in global water future. It's also been suggested that that's not enough to get people to use it, that we should engage in different ways with the private sector to increase model and data engagement. How would you see that moving forward in a way that still preserves the openness of what we're doing?
Yeah, you sort of broke up there, John, but I think I got most of it. So, the private sector is interesting, right? So if you think about things like the U.S. Army Corps of Engineers, an example, right? They develop their core systems. They're available to everybody. They're freely available. The source code is not always available, but hopefully we're working on that. And then the private sector comes in and does a lot of value-added things, right, to those codes. And so, maybe there's a way to kind of move that forward with the private sector so that, and the open licenses allow this, but you have this core modeling that's available, right? Consultants should be able to use it, but maybe they don't have time to figure out all the details. So maybe there's a way for the private sector to, build wrappers around some of these systems, right? Which is, I think, is fair. The other thing is, my experience tells me you don't, as a private consultant, you don't make money or a lot of money in the water sector, right? It's pretty difficult in terms of software. Where you actually can make a living, I think, is on the services side. And so if we make these things available, right, municipalities or local engineers want some interpretation. I think one of the big failures that I've seen is on the climate change side. We have all these great products, right? But a municipal engineer can't use them, right? And so hopefully our knowledge mobilization will help that move forward, and there could be room for private sector investment in making some of these things more digestible down the road. So.
Okay, great, thank you. And Mary Jane, a question for you. You've done such a superb job preserving knowledge of past generations, many generations. And in the 21st century, where there's so many distractions, how do we continue to preserve knowledge of your community and others in a way that the people in your community can pick it up, but also others, that knowledge can be shared in some appropriate way? You're muted right now.
There we go. Good. Oop.
Muted again.
It keeps. I hope this works.
Yeah, it's good.
It kept unmuting and then muting. We've got 10 miles comes down onto the dish. Right now, has declared of Indigenous languages, 2022 to 2032. In this decade, all of the people that have only had their language written in the human alphabet, using that kind of way of putting thoughts, stories, life, emotion onto paper, 1976. in our community, in our language. We're blessed that we had a young man that understood our grandmas and grandfathers, and at the same time decided to pursue linguistics. And this is why we had our language written. Right now, when you look at all of the work that you have done over the years, you could probably count on one or maybe two hands the language that is used in research, the First Nation Métis languages that are used in the research that you are doing. Very limited. Next decade to preserve the knowledge that goes with the language and the ability to continue to keep that oral traditions alive within First Nation, Inuit, and Métis communities to start to use the language, the place names. Our way, we say chew for water. Chew is so precious. Chew is when you drink it and it just so good. This is for us what water is. It revives us. It cleans us. When we are sick, it fixes our body. We have to remember we pack around water. Our bodies are walking water. We have to remember that. In our way, we've got so many ways to talk about water, to talk about the snow, to talk about the rain, to talk about what it is to hear. In our way, we say that at this time of the year, when the ice is getting honeycomb, when the water starts going through the ice and it starts to melt from the top down, not just the bottom up. A tundra, that is the honeycomb ice. When we listen, boy, we get excited. We like that. South wind comes and that ice starts to break up. That honeycomb, we know that springtime is coming. We still haven't even gotten that yet. Nai is when you hear that tinkling on know that the warmer weather is coming, that it's time you're going to start to travel on the land. How exciting that is. And all of that kind of knowledge is passed, that emotion is passed, and that ability in one word, you're telling that kind of expectation for the spring, the enjoyment of hearing that kind of tinkling on the ice. If there is opportunity within research to use First Nation, Inuit, and Métis languages, use that language, because that language has ancestral knowledge. That ancestral knowledge of land and water is important for the next generations. Kluane, good enough.
Well, thank you so much, and that's good advice, and that's I think and fruitful exercise to start to make sure that we can get this information out in Indigenous languages across Canada, because of the two-way learning that comes with that translation of concepts. I think we'll learn more than we think we will. That's my guess. So, thank you. Okay, a question for Al. What kind of licensing is or has the code been released under, or these models you discussed?
Yeah, so there's sort of some standards out there, right, for open source codes, and so I don't. Martin probably knows this better than I do, but there is an open source standard that we use, and all of our code actually states that up front, right? So I don't remember the exact name, and it has changed in the last little while, but we do use the I think it's OpenGL or something is the standard that we use for most of our codes.
Okay. Yeah, I know some of it we've been putting under FOSS, free and open source software licensing arrangements. Another question about some of the modeling. Is there any way to promote private sector investment and contribution to open source modeling initiatives, as is seen in other industrial sectors?
Yeah, Ari, that's a great question. I think there are ways to do it. We probably haven't done enough of that. There's probably, at least within Canada, there's probably ways through something like CWA to promote more of this, right? And let the private sector sort of do that next value added, or at least use the software. There's things that are changing, I think. If you look at the CWA Congress coming up here in June, what you'll see is there's a few workshops now that are dedicated to some of this. There's sessions on R, let's say, as an example, right? Kevin Shook is leading a session on R coding. So the private sector does have a chance to kind of get in on the ground floor on some of this and move it forward, right? But I haven't seen any initiatives at the university level to try to push this forward, and we see it a lot with industry, right? So, startups, that kind of thing. So there probably could be a push, and maybe that's something we should consider as GWF towards the end, right? To see how we move that forward. There is room for the private sector here for sure, and we should encourage that. So perhaps it's something we should focus on towards the end of GWF to see how that sort of next step can happen, right? So I'd say, yeah, there are ways to promote it now, but we probably could do more and maybe have a little bit of a thrust that way to bring the private sector into this, particularly the consulting community, I think.
Okay, great. And now I have a question for both of you. In Al's presentation, he talked about modeling human systems, social systems. And so I'll start with Mary Jane and then Al. But do you see ways that Indigenous communities could be included in models? And how would we bring in Indigenous languages to these models? And can we connect everything together in our models the way we know we ought to? But we still haven't done it yet.
I heard a little bit of what you said. Good, but what is it you're saying?
Oh, sorry. Yes. Can we bring Indigenous communities into modeling to bring their knowledge and the community itself, and use the models to connect that community to the natural environment? And do this as a way to help the communities manage themselves and their environment in the future.
Well, one thing in that I know that the value that is placed on documents, that are placed on written word, in many ways that kind of knowledge and the value of it is put down in young people right at the beginning of their life. You lay down with your little ones and you want to read them a book. That is you're teaching these young ones to lay down, be quiet, and listen to this book, because that value on that book is quiet. In our way, when we were raised up, we used to really work hard and make sure grandma's got lots of wood, lots of water. Give them extra berries if we got extra berries. Make sure they got lots of food. So time when grandma start to tell us or grandpa start to tell us stories, we all sit down and we listen. And our was the illustrations that we heard from these grandmothers and grandfathers. And we learned when they told us about water, when they told us how to behave on the land, how to respect each of the plant life and the animal life that we walk on, that we travel with, we learn to hear and respect that knowledge that they were sharing with us. They didn't tell us things just to joke with us. They love to laugh and tell funny stories, but what they told us about being on the land and water was to keep us safe, to make sure that we would be healthy, that we would always find food on this land and on this water that we travel on. So we have to make sure that that kind of knowledge within oral traditions have the space and the ways ethical space, have that space and allow that knowledge that is within oral traditions, within the language, to be able to share and give it value. Not just put it down as, oh, that's a legend, that's a myth, oh, that's storytelling. I really appreciate that, and it is not a checkbox. It is not a checkbox. So this means academia needs to rethink how it is looking at value and knowledge. The knowledge at this time, Western knowledge is only this big. The knowledge of ancestral knowledge is so far back, and it's still here today. So that kind of knowledge has value. If it has been passed on through the trauma that it has encountered to survive, definitely it has value. And that value needs acknowledged and accepted, not just as hearsay. Klahu, good finish.
John, if I could add to Mary, I mean, I can't agree more with Mary Jane, right? It can't be tokenism. It has to be real. It has to, have meaning. And we're just at the early days. I think, there's a lot of Indigenous scholars coming to universities now, right? And those of us trained in the more Western tradition are learning a lot about the Indigenous traditions, but we got a long way to go, right? But I think GWF has been great as a starting point, I think, for a lot of these discussions, right? And so I'm pretty optimistic that we will be able to build, talk to the knowledge keepers and build this into our understanding of how these systems work, right? And so that's a really exciting future, I think, for us in Canada for sure, right? So yeah, I'm really really excited about this possibility.
Thank you so much. You've both outlined how we can move forward together and the next great challenge and adventure for us in Canada and in water. I guess we better wrap up here in at 1:45 the next hour. Let's see, it's 11:45 Saskatchewan time, 1:45 Eastern time. We start the parallel scientific sessions. So you get a bit of a break, take a look at the posters, have some lunch, have some tea, go for a walk, all these good things. And we'll see you later this afternoon. Thank you all so much. And thank you to our marvelous, marvelous speakers.